Hello, welcome to the topic 2 review. I'm going to hit the highlights. You can go on Canvas and see the solutions. So like out of these I don't need to go through. You can just go look at the solutions. If you have any questions, you'll have to join the live link or something, or send me an email and we can figure it out. So let's work down here. It says write the following in if-then form. If it's a biconditional, use if and only if. So here we go. An obtuse angle has a measure between 90 and 180. So does obtuse imply 90 to 180? Yes, it does. So obtuse implies between 90 and 180. Does an angle between 90 and 180 imply obtuse? Yes, it does. So that works both ways. This is a biconditional, and we would write, I'm not going to write it, you can write it yourself. You can write an angle is obtuse if and only if the measure is between 90 and 180. If it's a biconditional, you can use if and only if. Next, I dance when it rains outside. Okay, so this was actually on the quiz, wasn't it? I reused this. I forgot to put this on here. Does dancing imply that it will rain? I would say no. Does raining imply that it will dance? That you will dance? Yes. Okay, that's what this is saying. It's saying when it rains, then you dance. So here's the if then. If it rains, then you dance. It'd be pretty ridiculous to say if you dance, then it rains. Unless you believe in that sort of thing. Anyway. Next. Converse, inverse, contrapositive. Alright, so the first we just have to write the if-then statement. Angles that form a linear pair are supplementary. So I'm going to abbreviate. If this is the test, you want to write this all out. Actually, it'll probably be multiple choice, so you'll just have to pick the right option. Angles that form a linear pair are supplementary. So that's basically what this is saying. It's saying that a linear pair implies supplementary. So this is like P implies Q is another way of saying. In this case, the P is linear pair and the Q is supplementary. So linear pair implies supplementary. That's true. That's true. Now, I know that this one is automatically going to be true because the statement and the contrapositive are always the same. They're logically equivalent, it's called. Alright, so let's work through this. The converse is Q implies P. So the converse of the statement would be supplementary angles imply linear pairs. If two angles are supplementary, then they are a linear pair. Here's an example right here. Look at this. These two angles are supplementary. They do add up to 180, but they are not a linear pair. They are vertical. So this is a counterexample. They are supplementary, check, but they do not make a linear pair. A counterexample has to meet the hypothesis, the first part, which is angles are supplementary, and contradict the second part, which is linear pair. So here it is. They contradict that. Inverse would be not P implies not Q. So for us, we would say, by the way, that makes that false. And also the inverse is also false because these are logically equivalent. There's no statement ever where you'd find the converse is true and the inverse is false. They will either both be false or they will both be true. So the inverse, it would be for us, not a linear pair implies not supplementary. If two angles are not a linear pair, then they are not supplementary. And the counterexample works as well. These angles are not a linear pair. However, they are supplementary. Okay, so this says that they're not supplementary, and here's an example of them being supplementary. And then the contrapositive is not Q implies not P, which for us would be not supplementary implies not a linear pair. And that is true. If you're not supplementary, you can't be a linear pair, because by definition, linear pairs have to be supplementary. So, alright, next. Say the following is true or false. Give a counter example. 3 points make a plane. That is false. Here's my counter example. These 3 points are making a line, not a plane. You have to have non-collinear in there for it to be true. If these 2 lines are perpendicular, meaning you're making a right angle, then the lines make congruent adjacent angles. Let's see, let's draw a picture. If they're perpendicular, then they make congruent adjacent angles. That's true. Then angles next to each other are the same. So that one's true. Postulates, properties, definitions, and theorems can be used in reasons as proofs. That's true. An angle bisector always creates 2 acute angles. Not true. If you have a straight angle, if you have a straight angle and you bisect it, then you get 2 right angles. So you could bisect a straight angle, so an angle bisector, check, creates 2 acute angles. You could create 2 right angles. If 2 angles make a linear pair, then one of the angles is obtuse and the other is acute. That is false again. Here's the counterexample that works. Same picture. These angles make a linear pair. Okay, so check, linear pair, check. But neither of these is obtuse or acute. They're both right. So that contradicts that statement right there. Explain the difference between inductive and deductive. Inductive is when you use a pattern. So like, it rained yesterday, it rained today. I think by using my inductive reasoning, it's going to rain tomorrow. I'm using a pattern to make a conclusion. Deductive reasoning is using facts to make a conclusion. The law of gravity says that if I throw something in the air, it will come back down. So therefore, I conclude that if I throw my pen in the air, it's going to come back down. I'm basing my reasoning on the law of gravity. It's an accepted truth. All right. Explain the difference between transitive property and substitution. There is a slight difference in these two. So here's the explanation. Here's a transitive property. A implies B, and B implies C. So all of this together would mean that A implies C. However, you could also call that a substitution. You could say, okay, A implies B. Let's replace the B with the C. So therefore, A implies C. That was substitution, where I replaced the B with a C. And so what we find out is that a transitive property situation is a special type of substitution. All transitive situations are technically substitutions. You're substituting in. Transitive is like a train, though. It's like a train of thought. You go to A to B, and then you go from B to C, which means you can go from A to C. It's like a train of thought. Here's strictly substitution. A plus B equals C. B equals X. Therefore, A plus X equals C. So what just happened is I replaced the B with the X. Now that was strictly substitution. That was not transitive. So transitive is a special type of substitution. All transitive is substitution, but not all substitution is transitive. Try to wrap your mind around that. Let's work through these. Determine if it's true or false. If 2 lines intersect and the intersection is exactly 1 line, that is false. If 2 lines intersect, they make 1 point. Make a point. If 2 planes intersect, then they make a line. Like this line right here. See this line? Two planes intersecting, they're making a line. Through any 3 points, there's a plane? No. Through any 3 non-collinear points, there's a plane. Yes. So non-collinear needs to be there. Excuse me. A line contains at least 2 points. Yes, the least amount of points to make a line is 2. You make 2 points, you make a line. If 2 points lie on a plane, then the line containing them lies on the plane. That's true. That's one of our postulates. So like here, for example, if B and A are on plane P, then the line containing B and A is also on plane P. Can you assume? Let's see. Can we assume that HC is perpendicular to GE? Well, look at this. We have a right angle symbol. It's hard to see, but it is there. So yeah, go ahead and assume that. Make that conclusion. Next. We have a little algebra proof. This is an algebra proof, not a geometric proof, because we're just doing the algebra. So get your statements and your reasons. Statements and reasons. So here we go. 5 plus 2x equals 4x minus 1 over 3. You always start with some piece of knowledge, and it has to be given to you, because we don't, I mean, is this true? Is this equal to that? I don't know. Sure, let's go for it. Let's see what we get. Let's use this information to prove this information. Use your given to make your proof. Now this is going to be the last line. It's nice because we know what the answer has to be. So the first thing I'm going to do is I'm going to start by multiplying the 3 over. And I'm going to do 2 steps in one here. So take this 3 and multiply it over. I can do that, and we're all good. And I'm going to distribute at the same time. Kind of cheating here a little bit. I did a multiplication. Multiplication. Did a multiplication and a distributive property in the same step. Took 3 over, 3 times 5, 3 times 2x. And then from here, I'm gonna bring the 4x. I'm gonna subtract the 4x. And I'm going to take the 15, and I'm also going to subtract it. So I kind of did 2 steps in one there as well, didn't I? I did like subtraction, but I did it twice. Subtraction property. And then lastly, x is equal to negative 8 by the division property. I did it. I started with this, and I ended with this. That's a proof. You start with your given, and you end with what you're trying to prove. What you're trying to prove. Next, let's prove this. I'm going to do a paragraph proof in this one. So given that 2 is congruent to 3, I could put that in my diagram like that. Okay, so as given, angle 2 is congruent to angle 3. Also, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. Think about that. Why is 1 congruent to 2 and 3 congruent to 4? Because of the vertical angle theorem. The vertical angle theorem says that vertical angles are congruent. I can put it all together now using the transitive property. Start with 1. 1 is congruent to angle 2. Angle 2 is congruent to angle 3. And angle 3 is congruent to angle 4. So therefore, it's a transitive property. I'm putting it together like a train of thought. I'm going to be lazy. Therefore, that's what therefore is mathematically. Angle 1 is congruent to angle 4 by the transitive property. Alright, now we gotta fill in the blank proof. You know what? Skip that. We're not putting, that's a segment proof. We're only going to do angle proofs and algebra proofs on the test, so skip that. Let's go down here to this one. There's no picture for this one. We don't need one. We can just go off of what we have. So it says angle 2 and 3 are complementary. Now complementary implies 1 and 2 add up to 90. That's what complementary means. Not 1 and 2, sorry, 3 and 2. 3 and 2. So that's what I'm going to start my proof with. I'm going to write this as a sentence. Because it is given that 3 and 2 are complementary, it is true that 2 and 3 add up to 90. The measure of angle 3 plus the measure of angle 2 equal 90. So see how I just took this sort of reasoning and wrote it as a sentence. It is also true, it is also given that the measure of angle 1 plus the measure of angle 2 is equal to 90. So here's what we got. This is informal. We've got 3 and 2 make 90. We've got 1 and 2 make 90. 90 is showing up twice. In this scenario, 90 is equal to that. In this scenario, 90 is equal to that. If these are both equal to 90, then they are equal to each other. And you can think of this as like a transitive property where you've got A is equal to B and B is equal to C. So A is equal to B and B is equal to C. Therefore A is equal to C. This is equal to this. So that's what I'm going to write up here. Therefore, by the transitive property, it is true that the measure of angle 1 plus the measure, actually, I'm going to write, let me use my first step first here. Let's use this. The measure of angle 3 plus the measure of angle 2. Notice I'm using measures. I add measures. I do not add angles. I add measures of the angles. It's a grammar thing. The measure of angle 1 plus the measure of angle 2. There it is, just like that. Now I can subtract the 2's. So I've got 3 and 1 left. And therefore, by definition of congruent angles, we have that angle 3 is congruent to angle 1, which is exactly what we were trying to prove. Now, for this one, I'm not going to do the algebra, but I am going to set up the problem. The problem looks like this. We've got vertical angles here. So there's that. This is a quadratic, and we're not going to put that math yet on the quiz, but it is coming soon. But you do need to know how to set up the equation. Here we got vertical angles, so we use the equal sign. Over here, there's a couple equations. We've got vertical angles here. We've got 20a plus 6b is equal to 60a minus 2b. So that's one equation. We've got a linear pair here. So we've got that 8b plus 20a plus 6b is equal to 180. And then we also have a linear pair here. So we've got that 8b plus 60a minus 2b is equal to 180. You do need to know how to set up those equations. And I'm not going to get into solving a system of equations right now. You can see the work on the solutions if you'd like to. Alright, that's all I have time for.